The 2005 South Carolina Master's exam requires advanced knowledge in several areas. Firstly, electrical theory and calculations are essential. Secondly, transformers must be well understood. Thirdly, motors and generators need to be studied. Fourthly, advanced electrical codes are a significant part of the exam. Fifthly, lighting systems knowledge is necessary. Sixthly, safety regulations need to be understood. Some individuals find the master's exam easier than the journeyman's exam because it emphasizes theoretical knowledge over practical skills. However, others find it more challenging because of the advanced concepts and complex calculations involved. To prepare for the exam, firstly, review the exam content outline. Secondly, focus on understanding the principles and formulas behind electrical theory. Thirdly, practice solving complex calculations. Fourthly, seek guidance from experienced electricians or study materials that cover advanced electrical concepts. Fifthly, allow ample time for preparation and do not underestimate the difficulty of the exam. Passing the master's exam provides recognition of advanced electrical knowledge and skills, firstly. Secondly, it offers potential career advancement opportunities. Thirdly, it increases credibility and respect in the industry. Fourthly, it provides eligibility for specialized electrical certifications and licenses. Let's delve deeper into the electrical theory aspect of the exam. Electrical theory encompasses the fundamental principles that govern the behavior of electrical circuits and systems. This includes understanding Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Knowing how to apply this law to series, parallel, and series parallel circuits is critical. You should also be familiar with Kirchhoff's current law, which states that the total current entering a junction is equal to the total current leaving the junction, and Kirchhoff's voltage law, which states that the sum of the voltages around any closed loop in a circuit is zero. Furthermore, understanding AC and DC circuits is essential. In DC circuits, the current flows in one direction only, while in AC circuits, the current changes direction periodically. You should know how to calculate voltage, current, and power in both types of circuits. This includes understanding concepts like RMS voltage, peak voltage, and power factor. Calculations will likely involve complex numbers to deal with AC circuit impedances. Moving on to transformers, these devices are used to step up or step down voltage levels in AC circuits. Understanding the principles of transformer operation, including the turns ratio, voltage ratio, and current ratio, is crucial. The turns ratio is the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. The voltage ratio is directly proportional to the turns ratio, while the current ratio is inversely proportional to the turns ratio. You should also be familiar with transformer losses, such as core losses and copper losses, and how to calculate transformer efficiency. Different transformer types such as autotransformers, isolation transformers, and three-phase transformers should be considered. Regarding motors and generators, these devices convert electrical energy into mechanical energy and vice versa. Understanding the different types of motors, such as induction motors, synchronous motors, and DC motors, is important. You should know the principles of operation of each type of motor, as well as their advantages and disadvantages. For example, induction motors are widely used due to their simplicity and reliability, while synchronous motors are used in applications where precise speed control is required. Similarly, understanding the different types of generators, such as synchronous generators and DC generators, is important. You should know how generators produce electrical energy and how to control their output voltage and frequency. Advanced electrical codes, primarily the National Electrical Code or NEC, are a critical part of the exam. Familiarity with the NEC is essential for ensuring safe and compliant electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. You should be familiar with the articles and sections of the NEC that are most relevant to electrical installations, such as Article 210 on branch circuits, Article 220 on feeder calculations, Article 250 on grounding and bonding, and Article 300 on wiring methods. Be sure to review the definitions in Article 100. Understanding how to apply the NEC to real-world situations is crucial for passing the exam. You should be able to interpret the code requirements and apply them to specific scenarios. For example, you should know how to calculate the ampacity of conductors, how to size overcurrent protection devices, and how to properly ground and bond electrical equipment. Let's discuss lighting systems. This includes understanding different types of lighting fixtures, such as incandescent, fluorescent, LED, and high-intensity discharge lamps. You should know the characteristics of each type of lamp, such as their efficacy, color rendering index, and lifespan. You should also be familiar with lighting design principles, such as illuminance, luminance, and glare control. Understanding how to calculate lighting levels and select appropriate lighting fixtures for different applications is important. Furthermore, you should be familiar with energy-efficient lighting technologies and strategies such as occupancy sensors, daylight harvesting, and dimming controls. These technologies can help to reduce energy consumption and improve the overall efficiency of lighting systems. Safety regulations are paramount in the electrical field. A thorough understanding of safety regulations is essential for preventing electrical accidents and injuries. This includes knowing how to identify electrical hazards, such as exposed live wires, damaged equipment, and improper grounding. You should also be familiar with safe work practices, such as lockout/tagout procedures, personal protective equipment requirements, and arc flash safety. Lockout/tagout procedures are used to de-energize electrical equipment before it is worked on, preventing accidental energization. Personal protective equipment, such as gloves, safety glasses, and arc flash suits, is used to protect workers from electrical hazards. Arc flash safety involves understanding the dangers of arc flash events and taking steps to mitigate the risks. Moreover, you should be familiar with emergency procedures, such as how to respond to electrical shocks, fires, and other emergencies. Knowing how to provide first aid to someone who has been electrically shocked is crucial. Finally, it is important to stay up to date on the latest safety regulations and best practices. The electrical industry is constantly evolving, and new safety regulations are frequently being introduced. By staying informed, you can help to ensure a safe and healthy work environment. When comparing the Master's exam to the Journeyman's exam, the distinction often lies in the depth and breadth of knowledge required. The Journeyman's exam typically focuses on practical application of electrical codes and basic electrical theory, while the Master's exam delves into more advanced concepts and complex calculations. For example, the Master's exam may require you to perform detailed voltage drop calculations, analyze complex circuit configurations, or design electrical systems for large commercial buildings. It is also important to note that the Master's exam may cover topics that are not included in the Journeyman's exam, such as advanced motor control, power quality, and renewable energy systems. This is why it is essential to thoroughly review the exam content outline and focus your studies on the areas where you need the most improvement. To maximize your chances of success on the Master's exam, it is crucial to have a solid understanding of the fundamental principles of electrical theory. This includes Ohm's law, Kirchhoff's laws, and the principles of AC and DC circuits. You should also be familiar with the different types of electrical components, such as resistors, capacitors, inductors, and transformers, and how they behave in circuits. In addition to understanding the principles of electrical theory, it is also important to be able to apply these principles to real-world situations. This requires practice solving complex calculations and analyzing circuit diagrams. There are many resources available to help you prepare for the Master's exam, such as textbooks, study guides, and online courses. It is important to choose resources that are aligned with the exam content outline and that provide plenty of opportunities for practice. Seeking guidance from experienced electricians can be invaluable in preparing for the Master's exam. They can provide insights into the types of questions that are likely to be asked on the exam, as well as tips and strategies for solving complex problems. Consider joining a local electrical trade association or attending workshops and seminars to network with other electricians and learn from their experiences. Effective time management is crucial for success on the master's exam. You will have a limited amount of time to answer all of the questions, so it is important to pace yourself and avoid spending too much time on any one question. Practice taking timed exams to get a feel for the pace required to complete the exam within the allotted time. If you get stuck on a question, don't be afraid to skip it and come back to it later. It is better to answer all of the questions that you know than to waste time struggling with the difficult question and run out of time to answer the easier ones. When taking the exam, read each question carefully and make sure that you understand what is being asked before attempting to answer it. Pay attention to the wording of the question and look for key words or phrases that may provide clues to the correct answer. Eliminate any answer choices that you know are incorrect and then choose the best answer from the remaining choices. If you are unsure of the answer, make an educated guess rather than leaving the question blank. There is no penalty for guessing, so you have nothing to lose by making a guess. Passing the master's exam can provide numerous benefits, including increased recognition of your advanced electrical knowledge and skills, potential career advancement opportunities, increased credibility and respect in the industry, and eligibility for specialized electrical certifications and licenses. With hard work, dedication, and thorough preparation, you can achieve your goal of passing the master's exam and advancing your career in the electrical field. Remember to focus on understanding the underlying principles of electrical theory, practicing complex calculations, and staying up to date on the latest electrical codes and safety regulations. The 2005 NEC is the specific edition for which the exam is based, so ensure that study materials and practice questions align with those requirements. Review tables such as 310.15, previously known as 310.16 for conductor ampacity, and understand how to apply correction and adjustment factors for ambient temperature and the number of conductors in a raceway. Grasp the rules for grounding and bonding, particularly those found in Article 250 of the NEC. This includes understanding the difference between equipment grounding conductors and equipment bonding jumpers, as well as the requirements for grounding electrode systems. Study motor control circuits and understand the functions of various motor starters, overload relays, and control devices. Learn how to troubleshoot motor control problems and how to properly size motor branch circuit conductors and overcurrent protection. Understand the principles of power quality and the causes and effects of common power quality problems, such as voltage sags, voltage swells, and harmonic distortion. Learn how to mitigate power quality problems using various techniques, such as surge suppressors, harmonic filters, and uninterruptible power supplies. Review the requirements for special occupancies, such as hazardous locations, health care facilities, and places of assembly. Understand the unique electrical requirements for these occupancies and how to ensure safe and compliant installations. Familiarize yourself with the requirements for renewable energy systems, such as solar photovoltaic systems and wind turbine systems. Understand how to size conductors and overcurrent protection for these systems and how to properly ground and bond them. Stay abreast of any changes or updates to the electrical codes and safety regulations that may affect your work. Attend continuing education courses and workshops to keep your knowledge and skills current. Remember, thorough preparation and a solid understanding of electrical theory and codes are the keys to success on the master's exam. Good luck with your preparations. Consider the impact of nonlinear loads on neutral conductors, particularly in three-phase systems. Harmonics generated by these loads can cause excessive current flow in the neutral, potentially overloading it. Understand how to calculate the neutral load and how to mitigate harmonic currents using appropriate filtering techniques. Review the requirements for fire alarm systems, including the types of circuits, wiring methods, and power supply requirements. Understand the importance of proper testing and maintenance of fire alarm systems to ensure their reliable operation. Study the requirements for emergency lighting systems, including the types of fixtures, battery backup requirements, and testing procedures. Understand the importance of emergency lighting in providing safe egress from buildings during power outages. Familiarize yourself with the requirements for data and communication systems, including the types of cables, connectors, and grounding requirements. Understand the importance of proper installation and termination of data cables to ensure reliable data transmission. Learn about the different types of overcurrent protection devices, such as fuses and circuit breakers, and understand their operating characteristics. Know how to select the appropriate overcurrent protection device for a given application based on the circuit ampacity and interrupting rating requirements. Study the requirements for hazardous locations, including the different classes and divisions of hazardous locations and the types of equipment that are permitted in each location. Understand the importance of using explosion-proof or intrinsically safe equipment in hazardous locations to prevent explosions and fires. Familiarize yourself with the requirements for swimming pools and spas, including the bonding requirements, ground fault circuit interrupter protection requirements, and the types of equipment that are permitted in the pool area. Understand the importance of these requirements in preventing electrical shock hazards in and around swimming pools and spas. In Greenville, South Carolina, and surrounding areas, electrical work must adhere to the locally adopted version of the NEC and any local amendments. Be sure to check with local authorities for any specific requirements that may be in effect in your jurisdiction. Passing the master's exam is a significant achievement that can open up new opportunities and enhance your career prospects. With thorough preparation and a commitment to excellence, you can achieve your goal of becoming a licensed master electrician.